The question of interest to many is how to maximize the return on investment in renewable energy. Each geographic location has specific climate and environmental circumstances, making different forms of renewable energy generation more efficient. During the year, seasonal patterns can shift the main benefits from one energy form to another. The energy consumption might be subject to fluctuation, or there are restrictions in terms of assets positioning. All those factors should be considered before investing time and money into any specific technology. Solar energy is becoming increasingly attractive even for higher latitude locations like North USA, Canada, and Northern Europe. Thus, in this brief article, we look at the impact of ice and snow on the yields of solar modules. As an aid, we are using a site environmental awareness report from @sea.fi, which can be easily obtained for any geographical location worldwide. Our @sea report has a handy table showing the annual sum of available solar energy in kilowatts per square meter for different mounting angles of solar panels. In another graphic, it shows the relative losses as percentage if we are unable to mount at the most efficient tilt and orientation. The report includes the monthly distributions for a few main tilt angles based on the location-specific simulation. In spring and fall, we could produce about as much electricity using wall-mounted panels with 90 degrees tilt as from panels mounted at optimum 50 degrees tilt. It is interesting, since vertical wall-mounted panels would be much less affected by snow accumulation. If we assume that snow and ice accumulation would make the modules unproductive over winter months and early spring, the annual loss would be an average of 240 kilowatt-hours per square meter, which is basically the sum of the output for late fall and spring months. However, for vertical mounting, the production would be significantly lower in summer months compared to optimum tilt. Counting the monthly difference in our plot, we find that it amounts to about 260 kilowatt-hours per square meter loss over a 6-month period, which is very similar to the losses of optimum mounting tilt due to snow and ice. To mitigate the losses of vertical mounting, simple engineering solutions exist, for example, lifting the panels 30 to 40 degrees away from the wall in the spring to achieve the optimum 50 to 60 degrees tilt angle for the summer season. It would mean repositioning the panels twice a year, probably a couple of minutes effort per module assuming cheap engineering. 20 modules would translate to about 2 hours labor per year. For the mounting at the optimum tilt, we are facing the ice and snow clearing issue, which might be particularly challenging on a steep rooftop. Climbing on icy roofs is extremely dangerous and should not be attempted. Thus, safe access is something to consider when selecting the position for the modules. The one-off access when modules are mounted is not the same as regular maintenance access. It is the main reason why many use their garden space rather than the rooftop for solar modules. Obviously, this depends on the availability of such space and the expected frequency that maintenance is required, for example cleaning in very dusty areas or, like in our case, removal of ice and snow. To estimate the frequency of the snow problem, we look at the number of wet days in combination with frost days for different months, which suggest that precipitation is in the form of snow and there's ice buildup. It seems that we have a very high fraction of days with precipitation, suggesting small amounts of snow every other day on average. A nightmare from the snow clearing perspective. But each location is different, and it is always worth evaluation on the case-by-case basis. Let's translate the ice and snow issue into monetary terms. At the optimum mounting tilt of 50 degrees and orientation of 20 degrees to the west, because our location has better afternoon sun, we could be getting 1,165 kilowatt-hours per square meter per year, assuming accessible position where ice and snow can be cleared regularly. With even a very modest electricity price of €0.40 per kilowatt-hour, average panel efficiency of 30%, and 40 square meters total module area, our location could produce annually about €5,600 worth of electricity. If snow and ice clearing is not addressed or wall-mounted panels are not tilted for the summer, our losses would mean a huge reduction by €12,000. In relation, the cost of quality location intelligence from @sea.fi, helping us to identify, quantify, and mitigate the losses, was just a fraction of it. The numbers from the Site Environmental Awareness Report are based on a combination of satellite and ground-based measurements with physical models, resulting in highly localized data. Locations just 50 kilometers away may have somewhat different available solar energy levels, but the approach on how to use data to optimize the positioning remains the same. Final position selection will be strongly affected by suitable mounting points within the property. To help potential prosumers and investors to make fact-based decisions without large upfront investment of their time or money, we designed a comprehensive location intelligence report available at etsy.fi. Thanks for watching this video. If you're interested in learning more about how environmental data can be used in different scenarios, press the subscribe button to see more videos and insights from our Analytics PyCon team.